So today I want to understand one really simple question. How does a neural network actually learn? And we always hear we train we train a model, right? And we give it some data, we train it, and somehow it's get better. And but I want to understand what's actually happening inside the training process. So today I focused on a few important ideas like prediction, loss, gradient, backpropagation, and gradientation. And basically, I understood it as a symbol loop. The model makes a prediction, then we measure how wrong it is, and we calculate the gradient and update the parameter, and then we do it again and again and again. And so let me break down the what's really simple example. And like how does a neural network actually learn? Let us go into next slide. Okay, so first we have our input, like this input. And so let's say I give the neural network an image of the number of 7 I already gave you. And this image goes into the network, and the network process using its current parameters. And finally we gives as prediction. And in this example, let's say the model prediction 3, and you can see here 3. And but the model prediction is 3, but obviously that's wrong, we already know, because our input is 7 but model predicted 3. And obviously it's wrong. And so now we have an important question. How wrong is the model? And basically loss is just a number that tells us how wrong the model's prediction is. And so here actual answer is 7, you can see here actual answer is 7, but model predicted 3. And so we get we get higher loss. And for example, if we are using squad error, we can check the difference between the prediction and the actual value, square it, and that I get. I'm not gonna deep into the math here, okay? And in this in here main ideas I want to understand it. Higher loss measure was prediction, and lower loss measure better prediction. And so during the training, our goal is basically to make this loss much smaller. And yeah, but what do we actually change inside neural network? We have parameter, and mainly these are in here, and weights and bias. And and I found it easier to think about them like knobs. And so imagine these are knobs of a model, okay? And during the training we adjust this value, and if we them in right away, the prediction become much better, okay? And yeah, okay. And then the loss can become smaller. And but now we have another question. And how do we know which parameters should change? That's where gradients become important here. And okay, let's move on to next slide. Okay, okay. So this is probably the most important part of what I learned today. And we basically have two direction here. Like we have forward pass. You can see here on this part, and another backward pass. But okay, and during the forward pass, input goes through the network. Input goes through this network. Okay. And we get the prediction. You can see here, like equal to 3. Okay. And then we calculate it is loss. Okay, here loss. Once you know the loss, and we go the backward through the network. You can see here that we go through this network. And this is called backpropagation. This is the most important part in here. Okay. And yeah, and yeah, and so basic idea is that we want to know uh, how much is parameter affected the loss. And so we calculate the gradients for the parameters. You can see here calculate the parameters for parameter, and the gradient tells us how the loss change when a parameter change. And this give us information about which direction we should move the parameter to reduce the loss. And that's where So that's why I remember this. It is like for instance, I say forward pass means and it makes a prediction, and the loss is measures the mistake, and like and finally and the back propagation is calculated how the parameters affect that mistake, and the gradient gives us as information we need to update them, and yeah, once we have those gradient we can update the parameters. Okay. Okay, so now we have the gradient, uh, but here question is, what do we actually do with them? And we use them to update the parameters, and this is the basic idea behind the gradient descent. Okay, and yeah, I actually found the hill analogy pretty useful here. Imagine this is a hill, and the size of the hill represent the loss. Okay, and we start somewhere over here, and we want to move toward to this lowest point. Okay, and the gradient gives us information about the direction we should move. Okay, and so we take small step, first step and another by another, and trying move toward to this lowest point, and this step is controlled by something called learning rate. Okay, so basically gradient descent about adjusting the parameters, so the loss become smaller. And we don't do this just once. Okay, and we repeat the process, repeat this process, and again and again. Okay, and hopefully the model gets better each and every our training. Okay. Okay, and okay, so here's the basic idea, but I didn't want to just understand this theoretical. Okay, and I wanted to actually see this is the process happening in the code. Okay, like practical, and so I made a really small example using PyTorch, and because my goal is here is not to build a complete model. Okay, I just want to understand the training loop first. First I need a model. Okay, and I'm keeping it really small, and I'm using linear layer with one input and one output. And so basically, this is just a tiny model that can learn simple relationship. And okay, you can see here now we have my training data. Okay, one maps to two, and two maps to four, and three maps to six. You can see here, and so the model needs to learn this simple relationship. Okay, and it's very simple data set. Okay, next I need a way to measure how wrong the model is. Okay, so I'm using mean square error or MSG. Okay, and here this is, and this compares the model's prediction with the actual values, and it gives us a model loss. Okay, and now I create the optimization. Okay, and I'm using SGD, which is stand for stochastic gradient descent, and I give it the model. I give the model parameters and the learning rate here. Okay, and the optimizer will just gradient to update those parameters. And the learning rate basically control how big each update is. Okay. Okay, and before before training, I also wanna know where the models start. Okay, and so I calculate the initial prediction. Okay, and the initial loss. Then later I can compare this with the final loss and see whether whether the model actually improved. And okay, so now we can start actually training. Okay, we get to actual now, and we get to the actual training loop. Okay, and so range is 100. 100 means I'm gonna repeat the process 100 times, and step is basically uh, uh, current iteration number. Okay? So inside the loop, best thing we do is makes a prediction. Okay, and we send our input through this model, and we get the current prediction. So this is our forward pass. Okay, and And next step is, and then then we calculate the loss. So we compare the prediction with the prediction with the actual values, and we get a number that tells us how wrong the model is currently is. Okay. And in next in here, for calculating the new gradients, I clear the old gradients. Okay. And by the templates and gradients by default. Okay. And so we need to clear them before the next backward pass. Okay. And mm, okay. And and this is probably most interesting and important line of me. Okay. This back progression. Okay. um and the lost backward, this where backpropagation happens, and the PyTorch start from the loss, and calculate and grain with the and respect to the model parameter. And yeah, so basically it's figure out how each parameter affected the loss. Okay. And yeah, so this is a backpropagation step from the this diagram. And and in here, and yeah, and now we have the gradient here. Okay. And okay, yeah. And so we need to we need to actually use them, and yeah, optimizer dot step, and update the model parameter using this gradient. Okay. And so the weights and bias gets slightly changed. Hopefully this direction that reduce the loss. Okay. And now we back to the beginning, and doing all again and again. Okay. Like 100 times. And so if I look at this whole loop, and it's actually the sum from the process we saw in the slide earlier. And first is predict, and then calculate the loss, and then then and calculate the loss, and then backpropagate, calculate the grade, and backpropagate and calculate the gradient. Okay. Then update the parameters in here in this case, and then repeat again. And yeah, that's basically training loop. Let me run this training loop, and just by clicking here, and it's running. Okay, it's running. Yeah, we got it. And yeah, okay. And we can actually see the results. The initial the initial loss was higher. Okay, and here you can see 8.9 for something. And and then and after draining, the loss become much smaller. Okay, in here you can see 0.0012 or something. Okay, right. Yeah, this is a final loss. So the model actually learned from the data. Okay. Point. And so this is what I understood from day one. And any neural network start with parameters, and it makes a prediction. We calculate the loss to measure the error, backpropagation, calculate and the gradients. Okay. And the the optimizer uses those gradients to update the parameters. Okay. In here, update the parameters, and then we repeat the process again and again. Okay. Repeat the process. And yeah. So the basic learning loop is predict, calculate the loss, and propagate, and update the parameters, and repeat again and again. Okay. This okay. For this, I knew these terms individually, like gradient, backpropagation, and optimization, and so on. But I didn't really have a clear picture of how all connect. So today I started connecting them together, and how then now I have a much better understanding of what actually happened during the training. Okay. I'm gonna go a little deeper into the into what actually happened inside this lost dot backward. Okay. And uh, how are this gradient actually calculated, and that's where our chain rules comes in. Okay. Yeah. Yeah. Mm, that's day one.